Okay, this assignment, geometric sequences, is very similar to our last assignment, arithmetic sequences. So you're going to find the next three terms, you're going to determine whether or not you have an arithmetic geometric sequence, you're going to find the nth term, and then you're going to write an explicit equation for a geometric sequence. So a geometric sequence is a sequence in which the ratio between successive terms is a constant. A ratio can be written several ways. We can say 1 is to 2, or what we're going to use is 1 divided by 2. And we're going to use the fraction a lot. So I give you what this is a sequence. This is known as your first term. And if you notice what's occurring each time, a sub 1 remains the same, but your r values are what are changing, and they're changing by a power. If you remember, to get from r squared to r cubed, it's the same as r squared times r, so we're multiplying by a factor of r each time until we get out to that nth term. So the common ratio r, this is the ratio between successive terms in a geometric sequence, and it's found by dividing any term by its previous term. So we're going to look at this, determine whether each sequence is arithmetic, geometric, or neither, and you're going to explain. So if we were to take a term, -4, and divide it by a previous term, we should get a value. This gives us -4. If I did the same thing with the next two, and took 16 divided by -4, I should get that same value, which is -4. Or I can say, what am I multiplying by to get to the next term, or dividing by? And you can see here that we're multiplying by a -4 each time to get to the next term. And so this would be geometric. And I'm going to erase that. We would say that this is a geometric sequence. And our reason is that the common ratio is -4. Okay, we look at our next term. We have 2, 8, 14, 20. We can see we're not multiplying by anything because this would multiply by 4, and 8 times 4 is not 14. So it can't be geometric. The next thing we're going to look at is it increasing by the same amount. Here it's adding 6, and then adding 8. So because it's not even adding by anything consistent, we say that it's neither. And our reason would be that there isn't a common ratio or difference. Okay, for our last one, it looks like it's getting smaller significantly each time, so I don't think we're going to be subtracting anything. So are we dividing by anything? We can take these two terms and take 128 divided by 256 and see if it reduces. It does, to give us 1/2. So this says if we multiply each term by 1/2, we should get the next term. So 64 times 1/2 is 32. So we can see that this is geometric. And the common ratio is 1/2. Okay, this says to find the next three terms in each sequence. So we first need to find what r is. To get from 1 to 3 and 3 to 9, we see that we're multiplying by 3, so r is 3. And to find our next term, we take this 9, multiply it by the common ratio 3 to get 27, multiply that by 3 to get 81, and multiply that by 3 to get 243. On our second one, you're going to look at what are we multiplying by to get to the next term, or dividing by. Here it looks like we're going to multiply by a -5. So we take this negative 5 times the negative 75 to get our next term, which is 375. We multiply that by negative 5 and get negative 1875, and then we multiply that by negative 5 and get 9,375. Okay, our formula for the nth term of a geometric sequence is a sub n. This is our nth term, is equal to a sub 1, which is our first term. And that r there represents the common ratio. And the n comes from this nth term, so if we had the 12th term, n would be 12. Okay, we're going to use that on this example 3. It says to write the equation for each geometric sequence, and I do have an error. This should say negative 24. So the first thing you're going to want to look for is r. So what value are we multiplying or dividing by each time? So here it looks like we're multiplying by negative 2. And then you also want to identify your first term, which is negative 6. Then to write the equation, we go a sub n equals a sub 1 times, and I like to put this one in parentheses, negative 2 raised to the n minus 1. And that's all you will do with this sequence. On the next sequence, you have to find r, so what's occurring each time? It looks like we're dividing by 2 each time, so r is 1/2. And our a sub 1, our first term, is 1. So to write our equation, a sub n equals a sub 1, which is 1, times r 1/2 to the n minus 1. Now remember that these go, that if you were to multiply this, you would have to do your powers or your exponents before the multiplication. And the last one, it says find the 12th term in the geometric sequence. So what you need to find first is, not d, but r. To find r, we're going to find out what's going on. It looks like it's multiplying by a negative 2. And once you have discovered that, we'll find our a sub 1 is 1. And n here, because it's finding the 12th term, is 12. So our a sub n is equal to 1 times r negative 2 to the n minus 1, so 12 minus 1. And from there we're going to just simplify that. Because this is a 1, you don't really need it. We have negative 2 to the 11th power, and negative 2 to the 11th power is negative 2,048. And you're going to use, you're not going to have examples exactly like this on your homework, but if you'll identify these 3 pieces, then you should be able to do any of those problems. So good luck with your assignment 5.5 Geometric Sequences worksheet.